Great.
Good evening. It's Ian again. I'm a little tired tonight, so this is going to be a really quick update. So I'm a little mad at the GFS model. I remember how I was showing you how I was going to do that ridiculous little move from South Carolina and then move inland across Georgia all the way to Columbus and start dropping rain again across the northern part of Florida. Well, the rest of the models are showing it was going to go up over South Carolina, North Carolina, and kind of just move so slow it was going to drop a whole bunch of rain on South and North Carolina and eventually Virginia, and that's exactly what's happening. So Debby is still existing as a depression. Right now, it's over North Carolina, about over the Raleigh-Durham area, and eventually it's lifting its way out to the northeast. So let me go you. I don't know where I get that from. Let me go over to the weather map here out of the Raleigh, North Carolina National Weather Service office, and as you can see, we have a tornado watch across the northeastern part of North Carolina from Jacksonville to Raleigh and up to Kill Devil Hills, and then Virginia Beach area covering Richmond and way out to Lynchburg along Interstate 81 in Virginia. So right now, Debbie is still causing a lot of grief there in Virginia and North Carolina. There's a ton of rain going on. Let me look at the radar out of Richmond, Virginia. And as you can see, there it is. There's actually some heavy rain hitting the Roanoke area, Adam Shorter. So I know you're getting a lot of rain and you're probably sick of that because you can't go out jogging right now. It's hitting Lexington, Lynchburg, Charlottesville, up here to Front Royal, Virginia. Over here in the rolling Blue Ridge Mountains, they're getting a lot of rain. Over here in North Carolina, actually, there really isn't as much going on. You can see how the low pressure is swirling right between Greensboro and Raleigh-Durham. And right now, over there in Winston-Salem, it's actually just drizzling a little bit. So it's kind of dry there, Rebecca. And let me look down here on the radar out of the southern part of North Carolina and see what's going on down here in the Wilmington area. And as you can see, I click on the map here, you can see, oh, there's some heavy stuff getting ready to hit. Well, it's hitting right over close to where my Aunt Linda lives in Clarkton. There's a nice heavy rain band. It's an outer band extending all the way from Charleston up here to just about 20, 30 miles east of Lumberton, North Carolina, but not quite hitting Wilmington, but it will come through Wilmington in the next hour and a half. It's going to rain pretty heavy. So let me skip on down here to Florida and show you how ridiculously hot it is. And there's a low chance of rain. Look at this. The nighttime low in Gainesville is 77. That is super warm. And that's typically what it's like in July, but or August, but it's very unpleasant when the nighttime lows are in the upper 70s. And right now the dew point temperatures are in the mid 70s, so humidities are getting up to around 100% in the early morning hours and overnight. And just I want to let everybody know, a lot of people assume that the humidity is like 80 to 90% all day in Florida in the summer, and that's not true. The humidity is a percentage of the air that's saturated, and the closer the dew point temperature gets to the actual air temperature, the higher the humidity is. And so during the day, as the temperature rises, the temperature, the air temperature moves farther away from the dew point temperature, so the humidity as a percentage drops. So even on the most humid days in Florida, the humidity is usually right around 50 to 60%. And at nighttime, it's like 80 to 90 to even 100%. And then during the winter, it's usually in the probably the 40 to 50% range at night and like 10 to 20% or 30% during the day on a really dry day. So just to let you know, that's how that works. We're going to look at the satellite imagery across the Atlantic because there's some chatter going on about a possible hurricane developing in the Southwest Atlantic, possibly by next week. And I believe that is true. And as you can see here, let me go here back to the annotation here, and I'll draw some stuff out here for you real quick, real quack. So let me use green. So here we go. As you can see, this spinny thing right here, this is an upper level area of low pressure. That's not a tropical system developing. Right out here, you have some extremely dry air. This is part of the Saharan air layer, or what meteorologists like to call SAL. That Saharan air layer comes off the northern part of Africa, and oftentimes there's little dust particles mixed in with it. And so that dust limits the amount of sunlight hitting the ocean, and because of it, the air mass is very dry, and hurricanes and tropical storms hate that. They can't develop. However, you can see along here, let me get a different color. You can see how the thunderstorm activity is blossoming along this area here. This is what they call the intertropical convergence zone, or the ITCZ. This is the main development region. Thunderstorms pop up all along here. You can see they go all the way across into the Eastern Pacific. And so I'm giving you a little meteorology um, lesson tonight without being a meteorologist, but this is what I've learned for 30 plus years of watching weather people on TV. And one thing I also wanted to point out, let me erase all of this. So this, I just showed you this upper level low. One of the things that's our friend and foe during the hurricane season are upper level areas of high pressure and upper level areas of low pressure, or troughs in the jet stream. Now, if you look carefully up here, let me make a real thick line here, like the thickest one you get. I'm gonna get blue for this. You can see right here, you have this is pretty much the jet stream right here across the United States. You can see it. You can see the flow pattern across the North Atlantic. That is the subtropical jet stream. And it lifts pretty far north during the summer. The polar jet stream is much further north. But this is what helps control the hurricane activity. And right out here, let me draw. This is where the Bermuda Azores high pressure areas, and the wind flow pattern around it goes something like this. And in some seasons, it extends much further west than other ones. In 2023, the high pressure, the Bermuda Azores high, was more like out here, and the flow pattern was around like this. I know that's very bad drawing, but basically, part of the reason the 2023 hurricane season was so nice for the U.S. is because this Bermuda Azores high was farther out to the east, and the wind pattern around it was like this. And so when the hurricanes were developing last year, they were taking paths like this out to sea. They were going like this. There was a bunch of them that developed and went just way out like that. Even the closest ones went way out to sea. Now, the only reason we got a hurricane last year is because Idalia developed right here and took a track, like this. That was Idalia from 2023. This year is different. This year we have a pattern where, let me draw that high pressure area again, if I can get the color to come up again. So basically, we have an upper level high pressure area out here now that's situated pretty far to the west. And so the flow pattern around it is more like this. Oh, I didn't want to get myself that big. Never mind. So that's kind of the problem we're facing right now, is this high pressure area is really big, and it's causing us to basically have a higher threat for hurricane activity, which is not good. Let me get myself out of the picture here. There we go. So let me get this eraser again. So as you can see, there's still plenty of dry air out here, but this activity is bubbling up. And what we might see happen over the next week is basically a low pressure area that's situated from a tropical wave. Here's the tropical wave right here. I'm gonna make the symbol like that. This feature here is going to track off to the west-northwest, and this air right here is going to be moistened up by the ITCZ that I talked earlier. And eventually, the National Hurricane Center and the computer models are saying that this general area right here is going to be the development zone. And depending on what happens with the jet stream, see, let me show you an example here real quick before I go. So this is a jet stream trough that I'm getting ready to show you. And I'm going to use blue. So once in a while, we get a kink in the jet stream like this, called a trough. And then it dips back up and goes way back out to sea. And the wind pattern like that is going like this. So when a hurricane is approaching from the southeast, guess what it's going to do? It's going to go whoop, right out to sea. On the other hand, if the trough, let me erase this. If the trough is further west, let's see, I'm going to do this. Get the green, get the blue again. Let's just say, for example, the trough is like this, much further west, and then we have a high pressure area out here like this, and the steering flow pattern is perfectly like that. Guess what? A hurricane developing in the Atlantic, let's just say this is the hurricane, it's going to be more likely to take a track like this, affecting the U.S. coast, Florida, or possibly going even further into the Gulf and then hitting the Gulf Coast like this, with a situation like this. And this right here that you see on the screen right now is the pattern that we are seeing this year. We see a high pressure system, upper level high, Bermuda Azores high that's much further west than last year. And we have troughs in the jet stream that are a little bit positioned. They're pretty been prominent in the east, but they're far enough west that the East Coast and Florida could be threatened this year. So this is all I've got to say for right now. I got to go because this video has gone on too long, but I will see you guys again at the next time I have a video. I will talk to you all later.